I'm going to walk us through an example of how to actually find this module n. So I'm going to start with the 5, 1 knot here, and I'm going to start by labeling my arcs. So this first arc that I see, I'm just going to label as A, and then I'm just going to pick B and C, D, and then E. Now, it really does not matter what I pick to be A, B, C, D, and E. It will work exactly the same with a different setup. Now I want to make sure and label each one of my crossings. So at this crossing, I have an A, a B, and then the C is the overcrossing. Here my overcrossing is B, C, and E. Then I have E, D, and B, D, E, and A, and then A, C, and D. The reason I'm doing this is because of the equation that we are actually trying to solve. So what we are doing is we are taking the undercrossings and adding them together, and we are setting them equivalent to 2 times the overcrossing mod n. I just use U's and O's here so that you could see under and over crossings. Now I need to set up these actual equations for each crossing. So if I do that, I'm going to have this one here is A plus B is equivalent to 2C mod n. Then I've got D plus C is equivalent to 2A mod n. I have here A plus E is equivalent to 2D mod n. And then I have D plus B is equivalent to 2E mod n. And last but not least, I have C plus E is equivalent to 2B mod n. Notice, just to check to make sure that I'm on the right track, I have all different letters here in all of my module n because that overcrossing is going to happen one time here in this particular knot. I have 5 crossings, I have 5 equations. So now I want to set up my coefficient matrix, and the way I'm going to do this is I'm actually going to set n equal to 0, so mod 0. So what that means is that basically anything can really be equivalent to mod 0 because anything times 0 is 0. So these equations I'm going to rearrange slightly. I'm going to say 2C minus A minus B equals 0. And then I'm going to say here 2A minus B minus C is equal to 0. 2D minus A minus E is equal to 0. 2E minus D minus B is equal to 0. And 2B minus C minus E is equal to 0. So when I have all these set up, I'm going to set up the coefficient matrix of these equations here. Now when I do this, I want to make sure to keep everything in line, so I'm going to go A, B, C, D, and E. I also want to make sure that I am putting the correct coefficients. So here you can see that we have positive 2's and all negative 1's for the remainder. So as I fill in my coefficient matrix, I'm going to have a number of zeros that are going to be filled in. 2, -1, -1, 0, 0, and 2, -1, -1. So there's my coefficient matrix. So in the previous slide, I mentioned that if the sum of the rows and columns is 0, you don't have to worry about which row and column you are taking out for your submatrix. So if you were to add all these rows and columns up each way, you would get 0 every time. So I'm just going to eliminate the last row and the last column just because it's easy. I'm going to get the following matrix. So if I want to find the determinant of this matrix, I'm just going to use a calculator that has matrix functions on it to cut down my work quite a bit. Remember, we actually want the absolute value of this determinant. So we are looking for the absolute value of this matrix. When I do that, my determinant is 5. So this means my colorability is modulo 5 for the 5, 1 knot.